This video will introduce you to capacitors. A capacitor is a device made of two conductors separated by some distance, and the purpose of a capacitor is to store electric potential energy. Capacitors are commonly used in many electronic devices. As a matter of fact, almost all electronic devices contain capacitors. A really great example of the use of a capacitor is thinking about an old school disposable camera. Perhaps you've used one of these before, maybe when you were a little kid. Often, to use a flash on a disposable camera, you have to press a button on the front of that disposable camera until a light comes on, indicating the flash is ready. Then, when you click to take the picture, you get a nice bright flash. What you were doing when you were holding down that button is doing something called charging the capacitor. And then when you press the button to take the photo, the capacitor releases a large amount of energy in a very short period of time, making your light bulb in your camera flash light up very brightly. So how exactly is this done? How is it that two conductors could store electric potential energy? Well, you already heard me talk about how these two conductors are charged. They become charged, meaning that these two conductors will end up, one will become positively charged and one will become negatively charged. And so, if one is positively charged and one is negatively charged, that tells me that there will be an electric field between these two conductors. Often, you will hear these conductors referred to as plates, no matter what their geometry is. So these two conductors could be two spheres that are separated by some distance, or perhaps two cylinders, or, as we'll learn a bit about later, two parallel plates as well. No matter their geometry, we'll often say the plates of the capacitor. We know that if there's an electric field between these conductors, that any charge moved from one conductor to another would gain or lose electric potential energy, depending on how it is moved. By having this electric field between the conductors, we say that this capacitor is storing electric potential energy. Capacitors are many different shapes and sizes. This picture shows just a few examples. Often they're as small as the head on a pin in many of our common electronics today, such as your cell phone or your laptop, but they can also be significantly larger. You'll see some examples in class of capacitors. Sometimes they have different colors indicating their measurement, and sometimes they're made of different materials and different geometries, but they all have the purpose of doing the same thing, storing electric potential energy. We said that they store this electric potential energy by becoming charged. So let's talk about exactly how that happens. Here I have a diagram indicating what a capacitor might look like before it is charged. So when it is completely neutral or uncharged. I have two parallel plates, at least they're depicted as parallel plates, but really these could be any two conductors. Right now they're neutral, and you'll see that they are connected to a battery and a switch. Right now that switch is open, meaning that there's no complete path for the charges to move. During the charging process, we close that switch, and the battery provides energy for electrons to leave one plate and travel around the circuit to the other plate, as you can see in the second picture here. So we have one electron that has left the plate on the right-hand side, has traveled through the battery and through the switch and the wires, and then it has found itself on the plate on the left-hand side. This happens quickly at first, many electrons leaving one plate and going to the other, because they're given energy by the battery to do so. But then, as time goes on, it is harder and harder to give those electrons enough energy to accumulate on one of the two plates. I'll also point out that these electrons that are moving, they're coming from one plate to the other. That means what one plate has lost, the other one has gained, so they'll have equal charge. In the final situation here, this capacitor is now fully charged. Now, fully charged does not necessarily mean that every single electron has left one plate and gone to the other. The number of electrons that leave one plate and go to the other depends on how much energy is provided by the battery. We'll learn that relationship in a later video or class. Instead, we'll have the majority of the electrons leaving, so that one plate becomes positively charged and one plate becomes negatively charged. Now we can use this capacitor in some other way to release that energy that's stored, so to move the electrons back to their original plates. To do this, we would need to disconnect the battery and provide a conducting path that goes from one plate to another. This brings up a really important safety consideration, because a capacitor will remain charged until you provide a conductive plate or conductive path from one plate to another. So if you ever find yourself taking apart or opening up something that is an electronic device, you should always assume that any capacitor inside of it is charged, meaning it could provide you with quite the shock if you are the conductive path going from one plate to another. Make sure that if you ever are opening up an electronic device, that you don't touch any of the capacitors. A safe way to discharge a capacitor or provide this conductive path from one plate to another to make it so the two plates are neutral once again would be to use something with an insulated handle and a metal tip. Depending on the size of the capacitor, a screwdriver may have enough of an insulated handle to provide a safe way of discharging the capacitor. That's the basics about how a capacitor works. We will, in the future, learn a bit about some of the math that we can do with capacitors.